Here we go. 2.7 absolute value inequalities, day 1. In lesson 2.6, we were actually working with absolute value equations. And we took our equation that said the absolute value of x equals 6. And we talked to the fact that the inside of this absolute value could equal 6 or positive 6. We said that we actually had two solutions, x equals 6 or x equals negative 6. We say or here because the number can't be both of those at the same time in an equation. So we either say x equals 6 or x equals negative 6. Part of what we did then with that work is then if you were to actually put these two on a number line, we would then make our number line. We'd have a single dot out at negative 6, and we'd have a single dot at 6. Now, when we did our work for lesson 2.6, we didn't actually make number lines for these. We just found our two solutions. But if you did make a number line, this is what it looked like. So now, then what's the difference between an absolute value equation and an absolute value inequality? Well, as with a regular situation where you have inequalities, they do still have more than one answer here. Absolute value equations only had 2, 1, or none. Inequalities will have many solutions. So let's start with a simpler one that doesn't involve as much, but we're going to say the absolute value then less than or equal to 6. So we're looking for the numbers that have an absolute value that is less than or equal to 6. As with we did up here in equations, we need to find the numbers that will fit in for x. Well, with equations, we broke this out and we said, all right, we're going to have one where it's the same and one that was the opposite. We'll do the same with inequalities, and we'll write it this way. We'll say x is less than or equal to 6, and then I have x, the opposite of x, is less than or equal to 6. So I have one that's the same, one that's the opposite, x, or its opposite, one of the two. Now we'll figure out whether this is an or an and in just a little bit. As I look at these two, I have x is less than or equal to 6. That's simplified. This inequality is not. I need to divide both sides by -1. So when I do that, I get x. And because I divided by a negative, I reverse my inequality symbol, -6. When we make our number line, and this is where we're going to make a decision as to whether we're dealing with an and situation or an or situation. We'll make our number line. We'll put -6 and 6 both on the number line. All right, and in the middle here is the number 0. Now let's take a look. X is less than or equal to 6. Well, that would mean I would have a bracket, and I would be shading this way. X is greater than or equal to -6 would mean a bracket, and I would be shading to the right. Now, less than or equal to 6. The numbers that are in here have to have an absolute value that is less than or equal to 6. Outside of -6 is -7. If I check this by placing -7 inside the absolute value of -7 is 7. Is 7 less than or equal to 6? No, it is not. That means this area out here doesn't work. If I plug in 0, my friend 0, is the absolute value of 0 less than or equal to 6? Yes, it is. 0 is less than 6. And I can test outside +6. Let's say we test 7 on the +7. What is the absolute value of 7? It's 7. 7 is not less than 6. So where did I have it that it worked? In between. In between. These are all the numbers in here that have an absolute value less than 6 spaces from 0. Absolute value is based off of the number 0. All of these numbers from -6 to 0, all are 6 spaces or less from 0. All the numbers from 6 to 0 are 6 spaces or less back to 0. So in this case, what is the word I would put in here? The word I put in is and. As we found in our shading, This is where it is common. Outside of this, we have answers that don't work under inequality symbols. Then, in other words, on this one, when it's less than symbol, we're going to use the word and for inequalities. Let's take a look at another one. Now I have the absolute value of x plus 2 is less than 1. All right, so we're going to keep things the same. X plus 2 is less than 1. And x, oops, my apologies. And the opposite of x plus 2 has to be less than 1. All right, so I have the same as it is, and I can have the opposite. Solve for the inequalities. Add 2 to both sides here. I'm sorry, my apologies. X minus 2 on both sides. Minus 2, minus 2. So x is less than negative 1. On this inequality, I need to distribute the negative, and I can say negative x, or the opposite of x, minus 2 is less than 1. Add 2 to both sides. The opposite of x is less than 3. Divide by negative 1 on both sides. X, switch my inequality symbol, is greater than negative 3. So I'm looking for those numbers, I'm going to put my numbers above, that are greater than negative 3 and less than negative 1. Parenthesis is where the numbers are going to be opening greater than negative 3, parenthesis less than negative 1, and I'm going to shade in between. Numbers on the outside. For example, if I test 0, 0 plus 2 is 2. The absolute value of 2 is 2. And is 2 less than 1? No, it is not. That area doesn't work. So in here I have an and. So x is less than 1, and x is greater than negative 3. There are many times you're going to be asked to put this in interval notation. So you'll be asked to graph and put an interval notation. The interval notation on this one would be parenthesis, negative 3, comma, negative 1. Going back to the first one we did, if we did an interval notation on that, it would be bracket, negative 6, comma 6, bracket. All right, so let's take a look at a couple problems from your book. Page 104, numbers 1 and number 5. And if you'd pause the video for a moment and try both of these problems, then restart the video, and you'll see me do the problems for you. All right, so pause the video and give it a shot. All right, thanks for giving them a try. Now we'll take a look at what they are. X, I will say that x has to be less than or equal to 4, the same, or the and then since it's less than, I'll say and. My opposite then is going to be the opposite of x is less than or equal to 4. X less than or equal to 4 is all done. This one I will divide by negative 1, and I say x is greater than or equal to negative 4. So I'm looking for those numbers that are less than or equal to 4 and greater than or equal to negative 4. If I graph that, I have a positive 4 here. I have a negative 4 here. And where are the numbers that have an absolute value less than 4? Again, in other words, when you have a less than, we are actually moving back towards 0 for absolute value. I'm starting at 4, less than 4, I'm moving back towards 0. I'm starting at negative 4, and I'm moving back towards 0. So I'll be shading in the middle again. The interval notation on both of these would be bracket, negative 4 to 4, bracket. For number 5, would be this way. X plus 3 is less than 2, and the opposite of x plus 3 is less than 2. X plus 3 is less than 2. Subtract 3 from both sides, and I say X is less than -1. And I'm going to distribute the negative. So I say the opposite of X, -3, is less than 2. Add 3 to both sides. The opposite of X is less than 5. Divide by -1. X, reverse my inequality symbol, is greater than 5. All right, so at this point, and not 5, greater than -5, -5. Sorry about that. Okay, dividing by a negative. So my line graph, oh, that's a bad line. We'll try that trick again. There we go. So my graph, -5, -1, and means it has to work for both. So these are parentheses on this one. And I shade in between because that's where the answers are common for the two. All right, let's move along. Let's take a look at the other situation. All of these problems that we did, if you take a notice, less than or equal to, less than, less than, less than or equal to. All right, so we're going to move on a page here, and now all of these will be greater than. So x, absolute value of x greater than 2. Now we are moving away from 0. Remember, absolute value, everything is how far is a number from 0. With an inequality now, this is greater than 2. That means I am moving away from 0. What numbers have an absolute value bigger than 2 spaces away from 0? I will still do the same thing I was doing with the other inequalities, and I will break it apart. The inside will be the same. Oops. X is greater than 2. And in this case, because I'm moving away from 0, it should be what? I have the opposite of x is greater than 2. I'll solve x dividing by a negative is less than -2. Okay, so in order to work here, I'm going to put my numbers on my number line. I have -2 here, and I have +2 here. If I shade these, I have x is greater than 2, parenthesis, shading to the right. -2, x is less than -2, and shading to the left. Now looking at the graph, can a number be less than -2 and greater than 2 at the same time? No, it can't. So in order for us to talk about this inequality situation, we have to use the word or. Solutions on this one will be greater than 2 or less than -2. My interval notation then is going to be parenthesis, and our buddy negative infinity, comma -2, parenthesis, union, parenthesis, 2, comma, infinity, parenthesis. Let's take a look at one that has a little more on the inside of the absolute value. So x minus 6 is greater than or equal to 3. This, again, greater than or more than 3 spaces away from 0. That means I'll have one thing on the left side of the number line going away. I'll have another thing on the right side, and it's going away. So I have to write x minus 6. The inside will be the same as it is, greater than or equal to 3, or the inside comes out to be the opposite. So now let's solve each inequality. Add 6 to both sides. X greater than or equal to 9. Distribute the negative sign. Subtract 6 on both sides. Divide by -1. Switch my inequality symbol. So I have x is greater than or equal to 9, or x is less than or equal to 3. 3, 9. This is an greater than or equal to. That means a bracket. Greater than means pointed away to the right. And I'm drawing my arrow here. Less than or equal to means a bracket on 3. Whoops, I missed. Sorry about that. And then I will shade to the left. I write my interval notation, parenthesis, negative, infinity, comma, 3, bracket, union, bracket, 9, comma, infinity, or Rascal infinity. All right. So from page 104, here are a couple of problems from your book. Take a moment, pause the video, please. Why don't you try these to see what you can get. All right, thanks for pausing the video. I'll go through these for you. X is greater than or equal to 3. That means I have the same on the inside. X is greater than 3, or the opposite of X is greater than 3. I solve this one by dividing by -1, switch my inequality. So I have X is greater than 3 or X is less than -3. Number line. It would help if I could draw straight. Number line. That's going to have to do. Okay, so I have -3. I have +3. I'm going away from +3 at a parenthesis on this one. Shading to the right. Big old arrow shaded. -3 going left. Parenthesis. Shading left. And there we go. Interval notation. Parenthesis. Negative infinity. Hey, there's a decent one. To -3. Parenthesis. Union. Parenthesis. 3, comma, infinity, parenthesis. 17, x plus 10. Inside will be the same as it is. Greater than or equal to 14. Or the opposite of x plus 10 is greater than or equal to 14. Solve the left inequality. Subtract 10 on both sides. X is greater than or equal to 4. Or. Now, another way you could do this piece right here, you don't have to do it this way, I'll show you this. This is -1 times the whole thing of x plus 10. If I wanted to, I can divide by -1, and I'm going to divide both sides by -1, so I do this, divided by -1, divided by -1, and I get x plus 10 less than or equal to -14. Then I can subtract 10, so x is less than or equal to -24. And then I can draw my number line. And I have 4. And this is a bracket going to the right, shaded. Then I have bracket going to the left with -24. And I'm shading to the left. Draw my arrow, color that in. Write my interval notation of parenthesis, negative, infinity, comma, 24. Just, I'm starting to get better at those infinity symbols, huh? Bracket, union, bracket, 4, comma, infinity, parenthesis. So there's what you should have gotten on those two problems. All right, one last little thing for you, okay? Something that I'm not going to actually tell you while watching the video here. There are problems where you can get all real numbers, and you can get the empty set with these. One of these two problems below here will give you the empty set for an answer, and the other will give you all real numbers. Take a look at these, see if you can figure out which is which. And after you watch the video, come and talk to me about it, and we'll see if you have it figured out correctly. Stop in class, you'll get your assignment. If you got any questions, please feel free to ask me. Thank you.